We're going to write numbers now in scientific notation or in scientific form. So here's what we do. To write a number in scientific notation, we're going to move the decimal point so there is one non-zero digit to the left. So look at down here. This number here that we've got down here, this is in scientific notation. Notice here's the decimal point, and to the left there is one non-zero digit. We don't want a zero here. This digit to the left has to be non-zero and only one of them. If the decimal point was right here, that would not work because there would be two non-zero digits. Then what we do is we multiply that result by a power of 10, right? So multiply by a power of 10, and the exponent on the 10, right? The exponent on the 10, this 5, all right, that's the absolute value, 5, of the number of places that we moved the decimal point. So we can see we moved the decimal point 5 places. Whatever number that is, that's take the absolute value of that, and that's the number of places we moved the decimal point to get this. So we must have moved it 5 places. Now, we're going to make the exponent positive if we moved the decimal point to the left. So if we move the decimal point to the left, we're going to make that number positive. If we move it to the right, we're going to make it negative, right? So a negative if it was moved to the right. So looking at this number, we have one non-zero digit to the left. The absolute value here is 5, so we must have moved the decimal point 5 places, and because this is positive, we know we moved it to the left. Now in example number 2 here, this is in scientific form because here's the decimal place, and there's one non-zero digit to its left. So that's good. And look at this, we're multiplying by a power of 10. Now, look at the absolute value here. The absolute value of this is 7. So we know we moved the decimal point 7 places. The negative sign tells us we moved it to the right. So we started with some number, we located the decimal point, and we moved it to the right 7 places. So let's look at both of these in more detail. Let's start with this first one. Look at this number over here. What it is 473,000. Now, there's an implied decimal point right here, and that implied decimal point is right there. Now, what we want to do is we want to move this decimal point, right? Move that decimal point so that we get it into this position where there's one non-zero digit to the left. So we're going to have to move it, right? We're going to move this 1, 2, 3, 4, 5. We're going to move that decimal point 5 places to the left. So when we do that, we're going to have, let's write it here, we're going to have 4.73. We can drop those zeros. So we're moving it to the left times the power of 10. Now how many places did we move it? We moved it 5. So I'm going to put that up here as our exponent, and we moved it to the left, so we make this exponent positive. And that's exactly what we had over here. So in the second example, let's look at this number here. What we want to do is we want to move this decimal point. We're going to have to move it all the way over here, right? Because if we move it here, we'll have one non-zero digit to the left, that 8, right? And that's what we've shown over here. Decimal point here, one non-zero digit to the left. But to do this, we're going to have to move the decimal point. So we're going to move it 1, 2, 3, 4, 5, 6, 7 places to the right. So we're moving it to the right. So now we're going to have this number, right? We're going to have what's left here. We're going to have the 8.161, and now multiply it by a power of 10. Now the number of places we moved it was 7, and we're moving it to the right, so we indicate that with a negative 7. Let's try some more examples. So here's a number, 543. Now this is small enough that we don't really need scientific form here, but let's just try it because it's small and easy to do. There's an implied decimal point right here. That implied decimal point is here, 543 point. Now what we're going to do is we want to move this decimal point until it's right here, because if I move it here, I've got one non-zero digit, the 5, to its left. So to do that, we're going to move it 2 places to the left. Then our number is going to look like this, 5.43. But now we have to, let's come over here. We multiply the result. Here's our result, 5.43. We multiply that by a power of 10. So here's our power of 10 times 10, and the exponent is going to be the absolute value of the number of places that we moved it. Well, we moved this 2 places, so our exponent is going to be a 2. Now, if we make this exponent positive, make it positive if we move that decimal point to the left. So make the exponent positive if the decimal point was moved to the left, which we did, right? We moved it to the left, so our exponent is going to be positive, which it is. Now, we would have made it negative if we moved to the right, but we didn't. So we moved to the left. So this number here, 543, in the scientific form, is this number, 5.43 times 10 squared. So in problem number 4, let's put this number here. It's a big number, right? 87 million. Let's put this into scientific form. So now there is an implied decimal here, right? It's right here. 87,000,000. There's an implied decimal point right there. And to put it into scientific form, we're going to move it 1, 2, 3, 4, 5, 6, 7 places, and we're going to the left. So we're going to write our number here as 8.7. We can drop those zeros, times 10. Now, we moved this decimal point 7 places, so we're going to write 7. And since we moved it to the left, we make this exponent positive. So we're going to leave it as 8.7 times 10 to the 7th. In problem number 5, we've got this small number. So there already is a decimal point here. So we're just going to move this decimal point 1, 2, 3, 4, 5, right? We're going to move it 5 places to the right. If we move it 5 places to the right, right here, there will be just the 4 to the left. That's a non-zero digit. So we'll have one non-zero digit to the left. So we're going to have this number, we're going to have this as 4.2, and then times the power of 10. Now, what are we going to put here for our exponent? That's going to be the number of places that we moved it. Now, we moved it 1, 2, 3, 4, 5. So we moved it 5 places, so we'll write a 5, but because we moved it to the right, we'll make it a negative 5. So now we've got it in scientific form. Now, this problem, we're going to go backwards. This number is already in scientific form. And what we want to do is go back to standard form. We want to just expand this. So notice what we've done here. We moved, look at this power of 10. We moved the decimal point 4 places, and because it's positive, we know we moved it 4 places to the left. So to get the decimal right here, we must have moved it 1, 2, 3, 4 places to the left. So to get it out, let's just go back. 1, 2, 3, 4 to the right. So let's take this decimal point and move it 1, 2, we'll have to add 2 zeros to get it to the right. So it's going to look like this. 5, and now 1, 2, 3, 4, right? Does that make sense? Here it is, 1, 2, 3, 4 to the right. For this problem, this is in scientific notation, but let's see if we can get it back into standard form. So we're going to move this decimal point how many places? 6. But which direction? Well, this is negative, so to get it into this form, we know we moved the decimal point 6 places to the left, right? So, I'm sorry, to the right. So to get it right here, we must have gone to the right 6 places. So we started with some number, we moved it 6 to the right, so 1, 2, 3, 4, 5, 6, and that put it right here. So to get it back, let's go 6 to the left. So let's try that. So we're going to have the 9, we're going to have the 9 and the 8, and now move this decimal point to the left 6 places. There's 1. So here's 1 already. We're going to need 5 zeros. So I'm going to write a 0, 0, 0, 0, 0. I think that's right, right? There's where it was. We'll go 1, 2, 3, 4, 5, 6. So I'm going to put that decimal point right there. So this number is going to be, we'll start with a starting 0. 1, 2, 3, 4, 5, and then the 9, 8. So in problem number 8 here, this number is not in scientific form, right? Here's the decimal point, but we have 3 non-zero digits to its left. So it looks like we got it started into scientific form, but didn't quite get there. So just to get this decimal point here, what did we do? Well, look over here. We moved it 9, and because the 9 is positive, we know we went to the left, right? So just to get the decimal here, we went 9 places to the left. But it looks like we didn't go far enough. We need to go, just up here is 9, we need to go 10, 11. So let's fix this. We're going to write this now as 4.835 times 10 to the 11th. How about this one up here, number 9? This is not in scientific form, right? Because to the left of the decimal point we have 3 non-zero digits, not 1. So to get the decimal point here, we must have moved it 13 places to the right, right? Because that's negative, so we know we went to the right. So if we go to the right 13 places, we ended up here. Well, it looks like we went too far. We need to back it off 2 places. So here it was originally, and we went 13 to the right. That got us here. Back it off 2 places. So we're going to write this now as 4.835 times 10 to the... Now, it was 13 up here. Back it off. 12, 11. So we still are going to write our negative 11 here. Look at this number here. This is not in scientific notation because here's the decimal point. We have a 0 to the left, not a non-zero. That has to be non-zero. So how did we get it here? Well, we moved it, let's look over here, 20 places. We moved that decimal point 20 places. That's negative, so we know we moved it to the right 20 places, right? It was here, we moved it 20 places to the right. So think about this. We started here, we moved it 20 to the right, that's got it here. But we didn't go far enough. We really needed it over here. So we went 20. 20 just gets us here. We wanted to go one more. So let's rewrite this now as 9.48 times 10 to the negative 21, right? Should be 21, right? 20 got us up to here. We need to go one more, 21. So 21 to the right. Let's change it up just a little bit. How about that same number, but now we'll just make it to the positive 20. So again, to get that decimal point here, we moved it. We moved it where? 20 places, but this is positive, so we know we moved it 20 to the left. We moved it 20 to the left, that got us here. Well, we wanted it here. So it looks like we went too far. So 20 took us all the way here, back it off 1 to 19. So we're going to write this now as 9.48 times 10 to the 19th.